Okay, so we're going to do these examples. We're going to state the domain and range of the following functions. I'll do both notations. If you're SL, you just need to know set notation. So let's have a look at this one first. Okay, so we have this point, 0, 2, which goes through. So the maximum of the y is going to be 2. And it gets to close to 0, but it never touches. Now the thing about this is x seems to just the arrows indicate that x keeps going on forever. Right? Now, to be quite honest with you, I think that blue dot, I'm not sure if that's inclusive or exclusive. I'm just going to take that as being exclusive. So in this case, we would just have x, let's use black, x is all real value. I kind of like to do a double line on the R to make it a big R. Now what about y? Well, here we go, set notation. The range is equal to curly bracket y. What are we? Well, it's got to be less than or equal to 2, greater than 0. There we have it. Now if I was to do that in interval notation, it would simply be y belongs to, well, it's not inclusive of 0, but it's inclusive of 2. There you have it. So that's that one. All right. I'll go down a size. Okay, now what about this one? Okay, well, here we have a few things going on. So let's think about the x. So x goes all the way this way, keeps going, x goes all the way this way, and all between 2 and -2. The only things that aren't allowed are these lines where x is equal to 2 and x is equal to -2. Okay, so that means that those are the restricted values. Sometimes we see that. So the domain, we could say, is equal to x cannot equal 2, -2. That's it. Otherwise, that's the only values I need to say. Everything else we just take as being, it must be that all other values of x are fine. All right? So then I say, okay, now if I was to do interval notation, might be a bit more tiresome. I could, for instance, do this. Well, it's from -infinity to -2, exclusive, and -2 to 2, exclusive, and 2 to infinity, exclusive, right? Never includes any of those values because it never touches it. So that would be a way to do that one. What about the range? Well, the range, actually, there's only one value that y never gets to. Oh, I correct that. There are two values that are important here. So in the case of y, define the variable, y is greater than 0, it never touches that, and y is less than or equal to -1. I'll let you think about how you might use interval notation for that. Right, now if we have a look at this one here, f of x is equal to 1 over x minus 1, the square root of x minus 1. So the square root of x minus 1, you cannot have a negative under it. And the fact it's in the, so square root tells me no 0. Oh, no negative, sorry. No negative. I'm getting ahead of myself. No negative. The denominator tells me you can't have no 0. So basically, this guy here, the denominator has to be greater than or equal, well, not greater than or equal to, just greater than, in this case, greater than 0. Well, what's the value that's going to make that square root greater than 0? And the answer is x has to be greater than 1. So the domain is equal to curly bracket x greater than 1. Interval notation would be x belongs to, well, it's exclusive, non-inclusive, right? And the upper interval is, in this case, infinity, and you can never get there. Now, Desmos would be a great resource to help you find out the y. So range, I'll put a question mark, and you could use Desmos to check that. And I'll do the last one and show you. We've got x squared minus 4. So that has to be greater than or equal to 0. It can be equal to 0 this time because it's not in a denominator. So basically what we're saying is x squared minus 4 is greater than or equal to 0. Okay, well, it's kind of not the easiest to think about, but this is, giving us a start sense. A lot of us aren't going to have to do inequalities, so use technology, and I will in a second. But basically it means that x is going to be greater than or equal to 2, or x is going to be less than or equal to minus 2. Now this would be a question with technology, so let's flip over and have a look. This is what I prepared earlier. This is what it looks like. And you can see that those values are 2 and minus 2. I just typed it in. And you can also see that the range is y is greater than or equal to 0. So I can do the following using the notation domain is equal to curly bracket x, define the variable, x is less than or equal to minus 2, and x is greater than or equal to 2, and the range is equal to y is the variable, y is greater than or equal to 0. And again, interval notation would look like this. It would be x is of the set of, or belongs to, well, from negative infinity to minus 2, but that's inclusive, and inclusive from 2 to infinity, but it can't be inclusive of infinity, and y belongs to, well, we're inclusive of 0 all the way up to infinity and non-inclusive. So there you have it. So we're going to work on 2C. Hop over to the next little slide, next little note page, and there's something else about composite function. Okay, thanks.